Hey everyone, today we will be working in Tableau, making a couple scatterplots for some data that I just made up. So, step one, we have to grab the data file. So I'm just going to go through Excel, and I used a lot of just random data set generation to make this. I did a random cognitive ability score from 50 to 100. And that was my predictor variable, and my outcome variable was frequency of mistakes. So theoretically, higher cognitive ability score would lead to lower frequency of mistakes, but because the data is completely randomized, it doesn't come out that way. So for starters, we have our categories and our variables and the observations for each of them. And for a couple of them, we're going to want to change to verbal things. So we're going to click string for gender, for example, and we're going to go to aliases. And essentially, we're not recoding the variable, we're just kind of renaming each instance. So we're going to go 1 is female, 2 is male, gender is a societal construct, so none of this really matters. But just for the assignment's sake, we're going to keep doing that. So we're going to do this for position as well. Position being, there's 3 different positions of the employee. So we're going to have associate, junior, and senior. Go back and capitalize that on that. And then ethnicity of the participants as well. Do the same thing, go down to aliases and go, I don't know, black, white, Asian, Hispanic. Alright, so this is our data set for the most part, but for the assignment, we wanted z-scores. So in order to get z-scores, we're going to want to click on this and create calculated field. And so there's no actual easy way to do z-scores in Tableau. You have to do this weird syntax calculation. So for starters, we're going to just name this cog z-score, so the z-score for cognitive ability. And I cheated a bit. I have a notepad of when I was practicing around with it, just to save a bit of time. Getting the z-scores for both cognitive ability, my predictor, and frequency of mistakes, my outcome variable. So I'm just going to control copy instead of typing it out or clicking through, paste, and just walking you through it real quick. So we're going to take the sum of cognitive ability score, which will basically be our individual observation, so our x, subtract window average of sum of cognitive ability score, which is our mean for the data set, all over window standard deviation, sum of cognitive ability score. So observation minus mean over standard deviation. It's the typical standard deviation calculation. And when we do that, we have a list here. They're all null because it hasn't really been connected to anything. So it's just kind of floating there. So we're going to do the same thing, create a calculated field for frequency of mistakes. We're going to call it Frick z-scores, the z-scores of Frick, and go on through and get the syntax for that as well. It's the exact same thing, just replaced the variable in there as appropriate. Backspacing a lot. Get rid of that. Control paste it in there. And so the same thing is going to happen. We're going to get a bunch of null values. And when we hover over this, it basically says it contains an aggregate calculation which only contains meaningful data in the visualization's level of detail. So basically we got to graph it to see anything. So that's all in the data source window. Now we're going to slide over to Sheets, not the Tillmans, just the Sheets. And hide title, because we don't really need it. We know what we're doing here, mostly, or shot in the dark. So we're going to take cognitive ability score, and we're going to slide it up to columns. Oops, that's not what I wanted. We got cognitive ability z-score up to columns, and we want frequency z-score as our rows. Now notice, although a chart appears, there's no data in it. So in order to put the data in it, we have to link those z-scores to actual information, and that actual information will be the actual cognitive ability score and the actual frequency of mistakes, as I understand it. So, I have no idea what that is. Control Z. So we're going to take frequency z-scores. Nope. Control Z again. I don't know what's happening. Frequency of mistakes. Why is it doing this? This is not what I'm telling it to do. One more try. There we go. So, we're going to want to scroll down and make this dimension for both of them. And as you, I don't know if you noticed or not, but the number of nulls increased. So it's recognizing that there's data, but it's not understanding how to plot them. So next we're going to scroll up here and compute using cognitive ability score. So we're going to match the z-score with the original score for that. And do the same for frequency of mistakes. Pop, pop. And boom, we have data. So there's still 15 nulls. And I'm not exactly sure where they're coming from, but I can filter some of them out. So we're going to move on. We're going to take age, and we want to sort the different sizes of the circles. So the older you are, the larger your circle. The younger you are, the smaller your circle. So we're going to scroll down, and it's going to be a discrete observation. So now each one of these is given its own size rather than grouping them in groups of 10. And we're going to want to put it in attribute, which will asterisk off one of the data sets. So these two circles, their ages don't appear because for some reason it's out of range or something. I'm not 100% sure why that is, but we're basically going to go over and exclude it, and those data points are going to disappear because we basically created a filter. Now we're going to do a similar process for gender, except we want to sort by color. So we're going to bring it over here. Gender appears down there. All of these are not gender 1. So in order to fix that problem, we scroll down and we hit attribute again. So now blue is female, orange is male. So when we hover over it, it has our female and it has our males. Next, we want to do ethnicity variable. So we slide that over to shape, and once again, it's in count rather than attribute. So when we click that, we have circles are Asians, squares are blacks, pluses are Hispanics, and X's are whites. Last thing we want to do, well, one of the last things that we want to do, is sort this out based on position. So we want to see what these variables are and how they look for the different positions. And when we initially put it up here, we get this weird funky output, basically because it's in count, and count ruins everything. So when we scroll down and drop it in attribute, bam, we have our associates here, anyone who's the associate rank here, anyone who's in the junior position here, and anyone who's in the senior position here. And next, we are going to want to add in the participant, just so that we can see what their participant ID is, so we can identify who is where. And so we have all this identifying information, but it's not really clear cut. So we're going to go in, tooltip, cheat it again, because I pre-wrote how I wanted it. So we're going to highlight that, control copy, and I'll read it off in a moment. But just deleting all of this. So we made it into a real sentence. So for participant, number of participant, how old you are, year old, blank blank. working in the blank position, they had a cognitive ability raw score, even though it's plotted as z-scores. We're going to focus on the raw scores of this, and had a frequency of mistakes of this. So ideally, what we wanted was the higher the cognitive ability score, the lower the frequency of mistakes, and that's what we would try to explain to a client. So now when we hover over them, it's still in sum. So you have to make that attribute. Nope. Just make it tooltip. Nope. For participant. How do we get it to tell us the participant number? It's connected. There we go. So for participant 46, 48-year-old Asian male working in the associate position, he had a cognitive ability raw score of 91 and had 10 mistakes this year. So that's kind of bad because the maximum number of mistakes was 15. So mistakes went from 1 to 15, and cognitive ability went from 50 to 100. So him having such a high raw score and so many mistakes is probably pretty bad. But let's get an overall trend line to see what we're working with. So we're going to go over here to analytics, slide down a trend line, and move over to linear, and we're going to get the most garbage trend lines. We have the greatest trend lines. So as you can see, we have a good slope. So we have the negative 0.04 slope. We want the slope to be negative. We want the higher cognitive ability score to kind of show lower mistakes. So we do want the negative slope, but this r squared is ridiculous. This 0.002, this data is not fitting our predicted models very well. And it's definitely not significant that p is 0.863, and this one's even worse. P is 0.89. As we scroll over here, so the trend lines are according to gender for each position. And so the closest one that we have to being both significant and being a decent fit is for males in the senior position. It has an r squared of 0.32 and a p-value of 0.052, so it's almost significant, but it's also positive. So something's going on with the seniors, in the male seniors, making a whole lot of mistakes. So if we were to give this to a company, we would probably suggest that there's something up with their test and the way that they're training people, maybe the measures that they're using to identify frequency of mistakes, because there's just a whole lot going wrong with this. So if this was an actual data set, there'd be a lot of problems, but it was just something that I randomly generated in Excel. Now, just throwing it out there, because I forgot to mention it, kind of glossed over it, the cognitive ability, the whole reason we put it in z-scores was to help identify and to help, well, we can use the z-scores to identify outliers. Nothing was outside of 2.58, which would kind of indicate an outlier on either scale. But we can also use it to identify, to standardize the scores so that they can be compared on the same line. So it's from negative 1.5 to 2, and this is also from negative 1.5 to positive 1.5 here, so it's easier to just compare them visually. If we would have had the raw scores, the data would have looked a whole lot different. Actually, since I have like 2 minutes left, I'm going to do that. Pull this out. Pull that out. And we're just going to throw in, oh god, I have no idea what that is. So this is what it would look like with just the raw data. You can see z-score. No, that's z-scores again, darn. Keep grabbing that. Number of mistakes. So when we switch it to dimension and dimension, this is what it looks like now. and our r's change, and our frequency of mistakes change, and our slopes change. So that's the graph. Thanks.